Hi folks, Harry Frank from Red Giant here, and in this tutorial we're going to continue our discussion on layer maps and explore a small section down here at the bottom of each of the layer maps, which is this x, y, and time equals z, or time equals z plus time. Now, in general, what you can kind of think of these as a sculpting tool for form, where in the z-axis we can have different shapes based on a different point in time from another layer. So here I have just a simple animated shape that goes from a star, and then I animate the number of points down to a circle, and also changes color over time. It's just using After Effects shape layers. Let's turn this layer off, create another form layer, and go to Trapcode Form. And I'm going to work with a box grid, and let's set a good number of particles in Z. Let's just start with 8 right now. And we'll spread these out just a little bit. Now, often when I work with form, I generally work with very few particles in Z. I generally work with kind of a single plane, or maybe a couple, but generally I just work with a plane. But in the case of this function where we're using Z and time, we need more than one, at least 2, if not more. More is preferable. So we'll work with 8. Now I'll go to layer maps, and I'll map the color and alpha from that layer. So this is my shape layer pre-comp. So I'll set that to shape layer comp, and then we'll map the red, green, and blue plus alpha to RGBA of form, and we'll map this over X and Y. Now, what we see is basically a direct representation of what the pre-comp is doing. Now, let's say we wanted to have each of these layers use a different point in time. Right now, Z has no other control. We can't say, well, Z is kind of not doing much for us. It's just kind of sitting there. So let's map the time factor of this composition here, that fourth dimension. We'll map that fourth dimension to the third dimension. And I know that sounds pretty out there, but it's not really that difficult. Now let's use this first one, xy time equals z. Now what we're going to see is that this doesn't change over time. It's simply staggering these layers in Z and picking points in space that are evenly divided amongst the number of particles you have, which is 8, and dividing it inside this time span that you have right here. Just so for easy math, I could set this to 4, and we have 8 particles in Z. So each point or each grid along Z would represent a half-second mark. But they don't change over time. This is just time equals Z. So our Z depth is mapped from the time of the external layer. If we add this second feature in here, which is time equals Z plus moving time, then we're going to actually see these change over time. Because not only is it applying the image over the z-axis, but it's adding time along with it. So time is actually going to progress. And as you can see, it's kind of staggered in time from one layer to the next. And that's really all there is to it. If you can think of, in this abstract manner, of mapping this third dimension of z and to this fourth dimension of your image, then that's really what we're doing. It's not something I use very often, but it is, as I mentioned earlier, a good sculpting tool. Everything we've done so far is generally grids of things, and this is a good way to have your shapes take on very different properties as they move through Z-space. So that's actually a very short lesson, but an description of how x, y, and then time can be mapped to z. And you'll find this function throughout these layer maps. Okay, so let's talk about one last section that we haven't covered yet, which is kaleidospace. Kaleidospace is very simple. Essentially, it is a mirroring function in trapcode form, but it's not an image-based mirror or kaleidoscopic function, unlike traditional filters that you might find in After Effects, where things render as a flat image. Trapcode form kaleidospace mirrors the particles in 3D space. So if I set this to horizontal, it's going to create a horizontal mirror point. So if I move these down, you can see that mirror point. And as I move them up, we can see that at the point where they intersect, the particles that would normally be duplicated are removed. And that's what mirror and remove means. I can also set this to a vertical mirror and move this along the x-axis. And again, you'll see that point where they mirror, the particles are removed. If I say mirror everything, it's going to overlap the particles like so. Now, you'll find some creative examples of these in the presets that are included with Trapcode Form, which if you go to the effects and presets, simply type TF2 for Trapcode Form 2. This was a new set that was added specifically for Trapcode Form 2.0. And if you poke through these, you'll find a couple examples that use kaleidospace in an interesting way. One of which is, this one's called Heaven's Door. Another is called Lacuna. And if we go to kaleidospace, try changing this to both horizontal and vertical and moving the shape around. So in short, Trapcode Form has limitless possibilities. So I encourage you to play with it, try all the parameters, try all the crazy things you can think of. It is a truly remarkable tool. I hope you've enjoyed this series of tutorials on how to work with Trapcode Form, learn it, and master it. My name's Harry Frank for Red Giant. Thank you so much for watching.